Hello and thanks for watching. My name is Angel Vilara and I am a network and security engineer at VMware. This is the fifth and last video of the series Security at Your Service. On the first video we have seen an introduction to the NSX Security Model and its distributed firewall. On the second video we have seen how to apply microsegmentation in a single data center. On the third video we have seen how to extend the microsegmentation concept across data centers. On the fourth video we have seen how to automate network and security with NSX and some cloud tools like VMware vRealize Automation and OpenStack. And on this video we will focus on some of the tools available to provide visibility and monitoring in an NSX environment. So let's start. In NSX there are two types of monitoring and visibility tools. On the one hand we have the traditional networking tools like SNMP, syslog, NetFlow, port mirroring or command line interface. And on the other hand we have additional NSX tools that simplify monitoring and troubleshooting. We have flow monitoring, which provides an overview of all the flows entering and exiting the NSX environment. We have trace flow, which is a functionality to introduce traffic between any two VMs and see how the traffic goes step by step and where it fails or if it's delivered properly. We have live flow, which is a graphical and easy to use tool to take a trace of the flows in the NIC of any VM, much like you would do with Wireshark. We also have vRealize Log Insight, which is much more than a log server. It provides out-of-the-box dashboards that make it very easy to analyze what's going on in your system based on its logs. And we also have vRealize Network Insight, which is a network analytics tool that provides correlation between physical and virtual networks, allows for planning and monitoring security, and a few other things. We will see demos of these 5 tools on this video. Let's start having a look at SNMP and CLI first. Regarding SNMP, the NSX manager is the responsible for sending traps of all the components of NSX. So there are traps in case there are any errors related to hypervisors, controllers, edges, or the manager itself. As you can see on the screen, up to 4 different SNMP receivers can be configured. In regards to CLI, despite NSX comprises different components, the manager, controllers, edges, hypervisors, etc., VMware has developed what we call central CLI, so you can access one single point and enter commands to get information from all components. So from the NSX Manager CLI, you can get information about MAC addresses, VMs, ARP tables, IP addresses, firewall rules being applied on any specific VM at any specific point in time, the flows on this VM, host status. You can even take a packet capture from this CLI, so in case you are troubleshooting and none other tool provides the information you are looking for from your desk, and without moving into the data center, you can take a trace of the relevant traffic for analysis of what's going on. So let's now look at the NSX additional tools. The first one is NSX Flow Monitoring, which provides an overview of all the flows entering and exiting the NSX environment, including a graphical representation. We can also get details of how many sessions and bytes correspond to each specific type of traffic, as well as the time at which those sessions took place. Also from this screen we can easily add a firewall rule in case we want to block that traffic. So let's go and see NSX Flow Monitoring in action. Flow Monitoring is located under the Tools section. The first thing to open is the dashboard, where we can see an overview of the flows with more presence in the environment, both in number and graphical view. We can hover the mouse over the different kinds of flows on the right, and they will be highlighted on the left, as you can see on the screen now. And each flow is highlighted in a different color, so that it's easy to identify it. Also we can put the mouse on the peaks to get more details of when they occurred. And also we can see information on the bytes, sessions and packets for each of the flows. We can move to the top destinations view, and we can see the layout is very similar, only that now information is organized based on top receivers or destinations instead of flows. The graphic works the same. We can hover the mouse over the different destinations so that the information is highlighted on the graphic in different colors as before. And if we check top sources, it's again the same, only that now information is organized by top talkers or top sources. Again we have the traffic, packets and sessions information, and below we have the graphical representation of the data. Next we can move to details by service, where we are presented more granular information of the flows we have seen in the previous windows. We need to check the time interval. By default it shows information on the last 15 minutes, and as you can see for now it's empty, so we will check what happened in the last hour. Here we have the information. In the top part of the screen we can select the specific traffic, and on the lowest part we can see details on the time the sessions happen, the source, the destination, how many packets, the firewall rule ID that allow the traffic, and in case we want to block it, we can easily create a new firewall rule or edit an existing one by clicking on the buttons on the right. So for now let's click on Add Rule. A new window pops up. We will give it a name to the new firewall rule we are creating, in this case Flow Monitoring Demo, and source, destination and service are already pre-configured with the details of the flow we are editing. We decide we want to block this traffic, and we want the firewall to do logging for the traffic it's blocking. We specify on which section of the firewall this rule will be created, and that's it. So let's go to the firewall and check everything works as expected, and that the rule is created as we have just configured it. So here we will open the NSX Distributed Firewall Rules section to find that the rule has been created with the configuration details we specified on the previous step. The next tool we are seeing is TraceFlow, which allows us to inject traffic on the virtual machine NIC to simulate a specific flow and see how it progresses step by step. So this way we can see if traffic is properly delivered at destination or if it's dropped at some point. We can even see if traffic is dropped in the step between hosts, which would indicate there is a physical issue we need to look at. So let's go and see TraceFlow in action. TraceFlow is also located under the Tools section, and the first thing we are doing in the example is to select the source VM. We can select the NIC in case the VM had multiple NICs, and then we can select the traffic type. In this case we are using unicast, and we are using TCP with a destination port 8080, and by default the ACK TCP flag is set. As the destination we select another VM, though there are other options, and again we select which NIC we are going to use. And we are leaving default values for timeout, frame size and TTL. So we hit on trace and the trace begins. So traffic is being injected and we are going to see the step-by-step path it follows. It takes some time to load the observations, but after a few seconds, here we have them. And we can see as traffic is injected on the source NIC that it goes through a firewall rule, gets to the logical switch of the source VM, gets to the logical router, then it's delivered to the logical switch of the destination VM, and then changes from one host to the other. Finally, at destination host, it goes to another firewall rule, and it's finally delivered at the destination VNIC. So in this case, everything has worked fine, traffic is delivered properly. So let's now go to the firewall and modify its configuration so that the default rule blocks all traffic. So let's change from allow to block, click on OK, and publish the changes. And next we will repeat the same TraceFlow to see what happens now. So back to the TraceFlow window, we will select the same source VM, webbo 180, the same NIC. We select the same protocol TCP and the same destination port 8080. All other parameters are left by default, and as destination we select the same destination VM, APO2 8080 and the same NIC. So we now hit trace and let's see what happens. It takes a few seconds for the observations to load, but once they are here we can see the output is now different. So traffic is being dropped by the firewall rule 1001. So as part of our troubleshooting task, let's go back to the firewall and find out which rule is that. There are different ways to finding out our specific rule. In this case, rule 1001 is the default rule, as you can see on the screen, but also we could have used the filter. So we can enter the rule ID, hit apply, and the search is done automatically for ourselves. And this is the way TraceFlow helps us troubleshooting our environment, in this case finding the rule that is blocking all traffic, so that we can take corrective action and solve the problem in just a few minutes. The next tool we are seeing is LiveFlow, which allows to take a trace of the flows on a VM VNIC with just a few clicks and without leaving your desk. Let's go and see the demo. Live Flow is located under Flow Monitoring. Once on its dedicated tab, the first thing we need to do is to select the VNIC we want to trace. So we click on Browse. We first select the VM and then the NIC among all that are available. In this case just one, because the VM only has one Ethernet NIC. Finally we click on Start and the trace actually starts. It takes a few seconds to retrieve data, but soon we will start seeing information. In this case, for example, we have one SSH session which is generated from this VM. We can see here there is a command SSH 172.16.10.11, which is the IP address of the VM we are monitoring. Back to the trace, we can look at the details like the status of the connection, source and destination IP address, amount of packets, of bytes, etc. And also you may have realized there is a color code that makes it easier to identify connections. So new connections are showing in green, terminated flows in red, flows with status changes in yellow, and all other traffic is shown in white. Let's now generate web requests to the VM we are monitoring. So we hit refresh on the browser and let's look at the trace, where we have a new TCP connection on port 80 and destination IP address 172.16.10.12, which is the web request we are issuing from the VM. So let's now modify the port of this request. So we are issuing a web request to port 1234, and let's see what happens on the trace. So we have new connections, but in this case they are terminated flows because there is no web server listening on the port. So here we have the port 1234 and the different attempts the VM is trying. Back to the connection that works, 172.16.10.11 on port 80. Again, we can see new connections on the trace corresponding to the new web request we are issuing from the other VM. The frequency at which data is refreshed can be modified so that it fits better our needs. And once we are done, we can hit on stop to analyze the trace carefully. And this concludes the demo of Live Flow, which as we have seen, it's a simple and easy way to get a trace of the flows on any VM VNIC. The next tool we are seeing is Log Insight, which is a log server with advanced analysis capabilities of unstructured data that provides intuitive out-of-the-box dashboards that make it very easy to understand potential issues in your infrastructure. The image on the screen corresponds to one of the NSX firewall dashboards where we can see source and destination IP addresses, allowed ports, blocked ports, etc. It's also important to note that NSX customers are entitled to use this tool at no additional charge. So let's go and see the demo. The first thing we need to do is to log into the tool with our credentials. In this case we are using an administrator user ID. And a few seconds after we are presented the list of available NSX dashboards, all of them out of the box. In this case on the screen we have the distributed firewall traffic one, which is the one showing top firewall sources, destinations, applications port permitted and denied, and a few other information we'll see later. On the top left corner we can change the time range to display information, so we are changing it from 24 hours to the last hour, and we can see how the panels are recalculated. If we scroll down, we can see how this dashboard has more information. So for example, we can see top talkers and top listeners on the infrastructure. Back to top, let's right click on one of the pipe portions, in top firewall destinations, the one related to 172.17.20.12, and we can see a context menu appears where we can select interactive analysis. I'm sorry the menu appears on the top left, this is because I'm using an unsupported browser. Interactive analysis takes us to the logs with destination 172.17.20.12 because this is what we have selected. On the top part of the screen we can find the filters we are using for the search of these logs, and on the lower part of the screen we can see all the logs as they are sent by NSX. Also we can select any field on the logs and by right clicking over it add it as a filter to the search so we can refine it to match our needs. Let's now have a quick view at other dashboards. So for example, we can see the distributed firewall overview, where we are presented a summary of information, like for example top rule hit count or firewall actions. And in this case we can see the top rule is 1001, which is the default rule of the firewall, and the most recent action is dropping traffic. And in case we believe that is not right, we should go again into interactive analysis to find out what's going on. Then we have distributed firewall alerts. where we can see top errors in our firewall environment. Luckily there is none in this lab environment. Distributed firewall traffic is the dashboard we have already seen at the beginning, so let's move to hypervisor data, where we can see the number of connections and the amount of traffic arranged by host or hypervisor. In this case we only have two, Virtual ESXi 01 and Virtual ESXi 03. And finally, on the rule data dashboard, we can see similar information, but now arranged not per hypervisor but per rule ID. So we can see connections and traffic sorted per rule number. And again, we can right click on any of the pipe portions to go into interactive analysis, to look at all logs and refine the search as per our convenience. And these out-of-the-box dashboards relate not only to the firewall, but as you can see on the left column, there are similar dashboards for logical switches, logical routers, for the whole infrastructure, and so on. The last tool we are going to see is vRealize Network Insight, formerly known as Arcing, which is a network analytics tool that provides visibility across virtual and multi-vendor physical networks, without requiring proprietary hardware or specific agents. It's simply based on a few virtual machines that take information from the infrastructure and compute it and analyze it. Let's go for the demo. This is the main dashboard of the tool. There are several interesting sections. For example, on the top left we have the plan security section. Below it we have the problem list, where we can see there are overlapping firewall rules. We can see there is a physical switch port dropping packets, and then on the right we have an overview of open problems, of east-west flows, of security changes, etc. We will look at these sections in more detail later, but for now let's focus on the search text box on top. Here we can use natural language to do the searches in our infrastructure. So let's say we are troubleshooting the connection between two VMs. We can ask the tool to show the connection between them. So let's enter VM admin VM6 to VM audit VM2 and hit enter. And only with that we can see a graphical representation of the path the traffic follows between them, including source and destination host, source and destination VLANs, and the physical switches the traffic goes through. And actually the graphic elements are interactive, so I can click on any of them to get more details. In this case we are seeing admin VM6 details. We can see to which VLAN it is connected, on which host is hosted, the default gateway, and many other things. We can also click on the host, so here we can see the number of VM it is hosting, how many CPUs it has, IP address, physical NICs, etc. We can do the same for the VLAN, so if we click on the source VLAN, the VLAN where the source VM is connected, we can see its VLAN ID, how many VMs are connected, etc. We can click on the host connection and we can see we are using VM NIC 3, its operational status, its MTU, VLANs, MAC addresses, etc. We can click on the physical device, on the physical switch. We can see it's using a VRF. We can see the routing table, the gateways, the MTU, the number of interfaces, the vendor, serial number, and many other things. And we can of course click on the elements on the right side of the graphic as well. So let's say now that instead of troubleshooting connection between two VMs, we want to troubleshoot the connection from one VM to a physical IP address. So we can enter the query. So as source we are using VM lab db2, and we want to see the path to IP address 192.168.10.1. We hit enter, and after a few seconds we have a similar graphic. In this case the graphic shows much more elements than before, so we will click quickly through them to see what they are. So first we have our source VM as before, in this case is lab db2. There are two firewalls. The first of them is the NSX firewall, and these are the rules protecting the VM. And if we click at the other firewall we can see it's a Palo Alto device and the rules that apply to our VM. Next we can click on the network that connects to the source VM, and we can see it's a VXLAN network called labdb, as well as the NSX controller managing it. The next element in the path is an NSX distributed router. Here we can see its name, the number of routes of interfaces, MTU, as well as the routes and interfaces themselves. The router delivers the traffic to a new network, which is lab transit network, so we can click on it and to check that it's a VXLAN network and its details. The next hop is an NSX edge, name provider edge, and again we can see its details. In this case it's running OSPF. It has 4 OSPF areas defined, and we can see the routing tables and the interfaces. The NSX edge delivers the traffic into a VLAN that connects to the physical world, and we can see the VLAN ID, how many VMs connect to this VLAN, and some other details. We can also click on the host interface that connects to the physical world to see that we are using VMNIC1, and we can see its speed, its MTU, its MAC address, and some more information. The next hop is a physical device, and we can click on it to see the same kind of information: vendor, serial number, routing table, routing interfaces, etc. And this router delivers traffic to a physical firewall, and again we can see vendor name, serial number, and some additional information. Finally, this firewall delivers the traffic into the internet or the WAN where the destination IP resides, but definitely out of the scope of the data center, so out of the scope for the tool too. Back to the home screen, let's have a look at plan security. Here we are presented a graphical representation of our resources and the flows that are exchanging between them. There are many things we can do here. For example, we can highlight one or the other group so that the graphic only shows the flows between them. And we can also change the criteria for the grouping. So at this moment we are seeing resources grouped by VLAN or VXLAN, and we can select any other choice. So for example, we can do it by IP subnet, or we can do it by vCenter folder, or also we can do it by NSX Security Group. In any case, we can click on any specific group to get more details. So in this, for example, we can see how many services are on the group. We have 6 VMs here, and we can apply different filters to this view. So for example, we can filter based on traffic rates, on allowed sessions, etc. We can also get information on the flows to access external services in a very similar way. And we can also get the full list of incoming and outgoing flows, so that we have a full view of what's going on this group. And based on all this information, vRealize Network Insight automatically provides recommendations to better secure the group. So in the example, we have 23 rules that we should implement in NSX to increase the security level in our infrastructure. Back to the main screen, let's look at the list of problems. There are several messages. For example, there are mask firewall rules, meaning that they are overlapping. And also we can see there is a physical switch dropping packets on port 15. So let's click on the switch name to get further details and to analyze what's going on. So one of the first things we can see is that the port is dropping packets at a rate of 40%. There have also been configuration changes, and if we scroll down we can see information on the switch itself, vendors, serial number, etc. And also that it's configured to use two VRFs, management and default. We can also see the switch port peers and the switch ports themselves. If we hover the mouse over 112 days, we can see when exactly the alert was raised. If we check the timeline, we can see it's pointing to that specific moment, but we can move around it so that we can see historical data to check if there have been configuration changes, for example. Looking at the switch ports, we can see there are 42, and we can see details about the speed, MTU, VLANs, and a few more information. For example, on port 15 we can see there are 6 problems detected. If we click on them, we can see further details of the port, like again speed, MTU, or MAC address, or VLANs, etc., but also information about the devices that are affected by this port dropping packets. And we could click on any of these links to get more information and continue troubleshooting, but we will leave it here for the sake of time. Let's go back to the main screen again to see what more information we can obtain from vRealize Network Insight. By using the search engine, we can retrieve information about almost anything in our network infrastructure. So for example, let's try to get a switch list ordered by switch vendor. For that, we enter the query switch order by vendor and hit enter, and then we will get our list of 36 switches. So let's have a look at it. We have 8 switches from one vendor, another switches from other vendors. Since the information is collapsed, let's click on show more, and we will get more elements on the list. Here they are. If we click show more again, we will get a new vendor, which is VMware. So we have the distributed switches by VMware at the bottom of the list. And this is a very easy way to get an inventory of our switches, no matter if they are virtual or physical. Let's see one last example of the power of the search engine of vRealize Network Insight. So let's try to find out the list of VMs belonging to a specific NSX security group. So let's write our query, VMs where security group is lab mid-tier. Let's hit enter, and in a few seconds we have the list of 14 VMs belonging to this specific security group. Actually, almost all of them belong to more than one security group. And again, we can click almost on any item on the list to get more information. In this case, we get the list of security groups where each VM belongs, but also we can click on the crosses on the right to expand each section and get more details about each VM. In this case, we get the IP address, we get the cluster, the host, and much more information. And these are just a few examples we have seen on this video, but you can try almost any search you can imagine in the search engine of vRealize Network Insight. And this concludes this demo and actually concludes the series, so I hope at this point I have convinced you that NSX provides better security because it is intrinsic to the infrastructure. It also provides streamlined operations and automated deployment, either with VMware or any other tool, and in summary, it's the platform to provide advanced networking and security for the new digital era. Again, thanks for watching. I hope you have enjoyed this video and the series, and don't forget to check my YouTube channel because all of these videos are uploaded there. Thank you.